Hi guys, this is Mrs. Ringrose, and it occurred to me that I needed to kind of go back and just make sure that everyone got a chance to hear how to do this problem. So we were looking at matrices, and there's this other vocabulary that you should be familiar with. It's called reduced row echelon form. And technically the definition of that is to get a diagonal of ones with zeros on everything else. And again, we're letting the calculator do that. We're using technology. Doing it by hand is something that you can easily learn. It's basically the same steps as if you were solving a system by elimination, but instead of carrying the x's and y's and the z's, you're just doing everything inside of a matrix. So we decided not to teach you that and skip over it. So the way you're going to use the technology is you're going to open up your Desmos calculator, your matrix calculator, and we're going to open up a new matrix, and we're going to actually put in the augmented matrix. So it's going to have those coefficients, and then it's going to have the totals. So I'm going to copy the matrix right over. Easy, easy. And then you have to hit enter so that you get these options. And then reduced row echelon form is this right here, RREF. So we're going to hit that, and then we're going to name our matrix, and then here's our answer right here. So this one represents that the first variable, maybe x, is equal to -2, and this one represents 1y is equal to -2, and then everything else needs to be zeros. If this was a 3 variable, maybe this was 5 and 9 and 10, and I'm just going to make up some numbers. They're ugly numbers, but see how you've got that diagonal of ones? This is what reduced row echelon form looks like. So I'm going to go back over here, and if the answer is looking for a reduced row echelon form, make sure you have a diagonal of ones, and everything else is zeros. And then our answers were -2 and -2, if I remember correctly. Whoopsies. So then you should check answer, and I'd be correct. So I think that pretty much covers it. You can solve, if all you're doing is solving it, you can also do it the way I taught you. But, I know what I want to cover. Why this is preferable. Because you can find out when it's infinitely many and no solution. So remember, I initially taught you this. And you would take the inverse of the first matrix and you would multiply it by the total matrix and see we get those same answers. X is -2, Y is -2. However, let's see, if we made these the same, 4 and -2, and I tried to do that, it would give me this caution, and we wouldn't know if this was supposed to be a no solution situation or an infinitely many solution situation. So using the reduced row echelon form, you can actually find out the answer very quickly. So what we're going to do is we're going to make, enter new matrix. We're going to do this one first, just really quickly. I want to make sure I'm using my augmented matrix. 2, 8, 6, -5, -20, and -15. And we did look at this one already, and I'm sure you can easily do this by hand. Enter reduced row echelon form, D. And notice there's that row of zeros in the bottom. So if one reduces, because I can divide 2, 8, and 6 by 2 and get 1, 4, and 3, and then the other one is a row of zeros, that means that it's all real numbers. Alright, so a row of zeros means all real numbers. And then what if I was doing the second one up there on my screen? So augmented matrix, 2, 4, 10, -1, -2, 2, enter, reduce row echelon form, E. And this one, I don't have a row of zeros, I have 0, 0, 1. So when there's x cancels out to 0, y cancels out to 0, and it's equal to 1 and not 0, then this one is your no solution situation. And you could solve this by hand, again, if you wanted to, and just confirm that. All right, so I hope this was helpful. Again, send me any of your questions you may have while you're preparing for the test.